Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. So let's look at another question for under electrolytic cell. So it says, in the electrolytic cell represented below, two carbon rods P and Q are used as electrodes, and concentrated copper chloride solution, concentrated copper 2 chloride solutions is used as an electrolyte. So when they use you as an electrolyte, it means whatever the electrode thereof, or rather the half cell, should contain something that has to do with whatever that is here. Let's say, remember, this is gonna be copper 2 plus and then Cl minus 2 Cl minus basically. Okay, so how do I know it is 2 Cl minus? Because for every 1 minus of copper you need, okay, for every 1 mole of copper 2 plus you will need 2 moles or whatever of Cl minus, because it can only accept 1. So you need 2 of them. Okay. And then it means somewhere, somehow we need to find copper. We need a copper in one of the electrodes, and then we need Cl2 in one of the electrodes. Okay. So, but how do I know which one is going to be which one? Remember, this is an electrolytic cell. The negative, it is the cathode. So cathode, remember, for cathode, I always say red cat. And then the positivity is the anode and ox. So remember, I said, what about the ions? Remember when we were talking about the salt bridge in one of the videos, the salt bridge. The salt bridge ensures cell neutrality. In this case, there is no salt bridge. But now what I said is that the cat ions move to the cathode, and then the n ions move to the anode. Cat, n, n. Okay, so this one will move here. Okay, the copper 2 plus. And remember, reduction is, remember, oil rig. Reduction is gain. So it means this copper 2 plus is going to gain electron to form what? Copper solid, like that. Okay. And then see, and oxidation, it is loss of electron. So it means this Cl minus is going to form Cl2. Let me say 2 Cl minus is going to form Cl2 plus, is going to lose electrons. Okay. And remember, oxidation, it is an increase in oxidation number from minus 2 to 0 there. Okay. So it can be something like this, possible something like this. Okay. So yes, define the term electrolysis. Remember, electrolysis, it is the process, chemical process, where electrical energy is converted to chemical energy. Okay. And then they ask us, what observation can be made at electrode P while the cell is operating? At electrode P, okay, remember, we are always forming at the cathode. Whatever that we are trying to form, we are going to form it at the cathode. Whether we are on a electrolytic cell or galvanic cell, at the cathode, it is where we are always forming. So if that's the case, if you are forming here, and can you see we are forming copper? Okay, if you are forming copper, it means there will be an increase in the mass of electrode P, because we are forming something. Okay, so I'm expecting an increase in mass of electrode P. Okay, an increase in mass of electrode P, or what can happen is that uh, there will be red brown deposits, or now you can say there will be copper deposits. But okay, the simple answer is that the mass will increase. The mass will increase because we are trying to form what? The copper the off. How do I know these electrolyte, sorry, that they used tells me what is we are trying to balance the off? Okay, yes. And remember, electrons will move from this part. Remember, electrons move from positive to negative. So if these are my electrons moving in that direction, and remember that I said the Cu2 plus is going to move to the cathode. So this Cu2 plus met with the what? With the 2 minus, and then it formed what? Or rather, let me say it, the Cu2 plus met with the electrons, and then what happened? It formed now copper. Okay, this one lost. This one lost. Okay, yes. So it means in this one there will be formation of a gas, formation of chlorine gas in this side. Okay. Write down write down the half reaction that takes place at electrode Q. Okay, this is now beautiful because we've already written everything down. Remember, this is just the formation of what? Of a chlorine gas. Guys, can you see I really use the table? Some people are so addicted to the table. Write down the name or formula of the reducing agent of this reaction. Which reaction? The reaction that we just wrote above. This one, reaction Q. Now, first thing first, what is the reducing agent? What is an agent? An agent, it is someone that does something to happen, okay? That makes something to happen. So if you are a reducing agent, if A reacts with B, and this one is a reducing agent, this one is a reduce. If A is a reducing agent, it means A causes this one to undergo reduction because it is an agent, causes reduction to occur, but on what? On B. So it means B will undergo what? Reduction. Whereas, remember, this is redox reaction. When the other goes reduction, the other goes oxidation. So it means A will undergo oxidation. So it means a reducing agent, it is a species or a substance that is oxidized or that undergoes oxidation. So a reduction agent, a reducing agent, it is a substance or a species that is oxidized. Which one is that? Which one had an increase in oxidation number? Remember, the one that had an increase in oxidation number, it is Cl minus, because its oxidation number increased from -1 to 0. Remember, pure elements have an oxidation number of 0. So Cl minus, it is the what? It is the reducing agent. It is the one that underwent oxidization. Okay, not Cl2, but rather Cl minus. Very, very important. Very, very key. What is the function of Cu2 plus CuC, copper, let me call it by name, copper chloride, as an electrode in the cell? What is the function of an electrode? Well, the function of an electrode, it is to do what? Yes, it will conduct electricity through the movement of ions, okay? It conducts electricity through the movement of ions. So it's just basically you defining what? Electrolyte. And then they now tell you that this cell is now used to refining of copper. Okay, so they will be refining copper, meaning maybe we'll be having an impure copper, and then that impure copper they are trying to do what? To take away the what? The copper the off. Okay, they're trying to take away the copper the off. Okay, and then the question is, which electrode PQ will have to be replaced with pure copper during refining process? Okay, which electrode will be which electrode pure Q will have to be replaced with pure copper during the refining process? So which electrode? We're gonna say electrode P. Why electrode P? Because electrode P, it is where we are forming our what? Our copper. Okay, so I'm gonna say it is electrode P. Why? It is because pure copper forms in there. Okay, forms again, forms through reduction of Cu2 plus. Okay, or you can say through reduction of copper 2 plus at the cathode. Okay, so the pure copper, the first market is P. Why? It is because the pure copper forms through the reduction of copper 2 plus, okay, at the cathode. through the reduction of copper 2 plus at the cathode to what? To copper. So hence it should now be put in this place, the off in electrode P. Our what? Our electrode. Okay, our copper that will be refined the off. And then they say explain why the concentration of the ions in the solution remains constant. Okay, this question is because now the rate of the forward is equal to the rate of the reverse. If the rate of the forward is equal to the rate of the reverse, everything remains constant. Remember, when we have chemical equilibrium, we are saying when the concentration of the forward, okay, the concentration of the reactants and the concentration of the um, product remains constant. But in this case, we won't answer using Le Chatelier exactly, but we'll rather say what? We will rather say uh, the rate of reduction is equal the rate of oxidation. Yes, because now we know when you use Le Chatelier on Le Chatelier's principle, we are saying the rate of the forward is equal to the rate of the reverse reaction, meaning now the reaction it is balanced. So there is no imbalance where the other reaction is favored more than the other. Why? Because if that was the case, there will be more concentration of maybe Cu2 plus more than Cl minus, causing an imbalance. So, and then silver and platinum are formed at the bottom of the container during the refining process of impure copper. So silver and platinum are formed at the bottom. They are not formed at the cathode. Okay, they are not formed here at the cathode, but rather they are formed at the bottom. Why is that? Why is that? It is because during refining of impure copper, okay, during refining of impure copper, let's say this is impure copper. We had copper, we had silver, we had platinum, okay, and they were all fighting for the position of undergoing what? A reduction. Okay, they were all fighting for to undergo reduction, whereas on this one we had an undergoing oxidation, okay, which was our Cl minus, okay, forming a Cl2 plus 2 electrons. So between these three elements, one of them should now overcome the other ones. But which one is that? So it happened that copper is the one that overcame silver and Pt for the place of becoming the one that takes the place where in this half cell there. And then if that happened, then copper was the one that was formed. And then these two, they did not form ions, okay? These ones, they did not form ions because they were just there, okay? They were just formed at the bottom like that. They say refer to the relative strength of reducing agent to explain why these two metals do not form ions. This is because, let me check my table. Let me check silver, okay? I'm going to check silver, I'm going to check copper. Here is copper. Silver, where is silver and platinum? Let me see silver. Okay, I always struggle to find this. Here is silver. I'm just left with platinum. Here is platinum. So they say to us, let's refer to what? To the strength of a reducing agent. Okay, can you see now? The reducing agent increase as you move upward. So we detect that, remember it increases as you move upwards. We detect that this one, remember you're comparing these ones when you're comparing about reducing agent. When you're comparing about a oxidizing agent, you're comparing these ones. In this case, you're comparing reducing agent. Can you see that copper is a stronger reducing agent than both AEG and PT. Okay, so we're gonna say first thing first, copper is a stronger reducing agent than AG and PT. Mind you, remember, if you are a stronger reducing agent, it means you will win the position of reducing the other one, and when the other one will make you to undergo oxidation. So copper is a stronger reducing agent than these two. So it means now copper will be oxidized. Okay? It means now copper will be oxidized. Okay? And then hence, okay, hence there will now be, hence now our copper will be oxidized. Or you can say Ag and Pt are weaker reducing agents than copper. And then, and they will not be oxidized. For you to be oxidized, you need to come with your ability to reduce the others. Okay, if I'm strong at reducing the other one, so the other one will be attracted to me because I have the capability to reduce him or her more, and then he will do what? He will oxidize me. Okay, so that's that basically, my good people. I hope it does make sense. So now that's when Copper decided to win the race, and then we formed it here. Whereas on this one we formed Cl2, and then and then and then that's when we had our thingy there off. Okay, and then remember here we had sodium chloride. Not sodium chloride. I'm lying. Copper chloride. So yeah, that's basically that, guys. So it means now copper won the what? Won the fight. So yeah, that's basically how you can answer this question of. Hopefully it makes sense. So thank you very much, folks. Let's meet on the other one.